बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Oh my God, give me courage and give me the skills so that whatever I am explaining is reach to the masses I am trying to explain. Uh, this is Dr. Adnan Qadir, and the concepts of how the plan mass transit and what are the models will be discussed in this lecture. Before we go, let's try to have some important terminologies that will be used frequently. The first word is the trip. It's a one-way movement from a point of origin to a point of destination. We are usually interested in the all vehicular trips. For instance, if I leave for the university, this is my one trip, and when I leave from university to my home, this is another trip. So the word trip means one end journey from one place to another. Then we can categorize as the home-based or non-home-based trip. This is where the trip maker is either the origin or the destination of the journey. For visitors from another city, the hotel acts as a temporary home in most cities. Non-home based trip means where neither end the trip of the head. This conversely is one where neither end of the trip is the home of the traveler. The uh, terminology continues. Is the production where you have started the trip. This is my production, and attraction is where you want to go. First is the shopping. If I want to go to shopping, because my need is shopping, I'm going to this shopping center is attracting me. Trip generation, total number of trips generated by a household in a zone. They may be home-based or non-home based. This is what most models would produce. A task then remains to allocate non-home based trips to another zones as a trip production. Now we come to the another term. This is called travel demand modeling. It is the modeling means to establish the spatial distribution of travel explicitly by means of an appropriate system of zone. So modeling of demand thus implies a procedure for predicting what travel decisions people would like to make given the generalized travel costs of each alternatives. The base decision includes the choice of destination, the choice of the boat, and the choice of the route. Although various modeling approaches are adopted, the classical transport model, popularly known as four-stage model, will be discussed during this lecture. So, TDM, the travel demand model, are often abbreviated as used to forecast traffic flows on the transportation system. Although transportation system may include other modes of travel, such as walking, bike, or trains, the models are typically used for evaluating roadway improvement or improvement to bus services. TDMs can be used to determine the impact of any proposed policy measures. When we say TDM, it means it includes elements such as roadway and transit network and population and employment data to calculate the expected demand for transportation facilities. Within this model, mathematical equations are used to represent each individual decisions making process of why, when, where, and how to make the trip, and what routes to follow to complete the trip. This model, the model result for these individual choices are combined so that the aggregates impacts of roadway vehicle volumes and transit route ridership on average travel times can be determined. This is a classic example of various places. As you can see, we have divided one area into uh, different places, and we have tried based on survey how much trip uh, start for say KR to USG, and we draw and how much trip from US to KR. So we draw a diagram that is straight line diagram that is also called desire diagram. So when we connect each of those say KR to the other destination so that we can know which which route or which origin destination are mostly followed, mostly required. So if you can see from this diagram, the whole of the diagram, you find that the largest number of routes is means larger of number of trips are being generated between USG and PRA. And it seems that PRA has also got some attraction from other sources at PLZ and say LIB or KHK. So, so we can say that from this diagram, PRA is the most likely destination of the people in this area or in this zones or in this district. And if we can look at this diagram as well, we say the thinnest line is between, let's say, MSK to YVVS. So it is the least population demand. So what we do in travel demand, we try to model, our priority will then be modeling a road between USG and PR. This is another, this is use of software application where you can find the most likely travel between the two places. What are the stages of transportation model? We first collect databases based on the network zones. Then we have the base area data, and then we have a future planning data. Based on that, we try to understand, we try to estimate how many trips are generated, how these trips are distributed between the zones, what mode of transport means car, transit, maybe vehicle, maybe motorcycle or walking, any other thing that is been used between those trips and the road. What are the alternatives? The trip has, the people has taken the routes to their destination. And then output lane, from that we'll find the final matrix, what we call the trip matrix, that shows you how, when, and what are the ways that trips has been generated. Now we come briefly to the steps of planning. Trip generation analyze the general infrastructure in a defined region. It characterizes the frequency of travel in each zone based on origin, destination, and purpose. Individual segments can be further analyzed based on land use, demographic, socioeconomic factors, and other key characteristics. So the classical trip generation has origin, trip generated by zone I, as a function of many other factors. X1, X2, X3, these are the variables. And the trip generation, the distribution, the trip attracted is the land use property. For example, the social and economic that we have four people, number of household, say four people, and the four of them are going to the job. You get number of people taking the trips, And it is also the function of the vehicles that has been used between the two zone, between for these trips, and any other factor for that. For example, if the household is poor, is a middle class, or anything, you can say how can you rank them socially. This attraction is where you have this trip generated. For example, this can be a function of YJ1 maybe the shopping areas, YJ2 may be the school areas, and YJ3 may be the office areas. So where the the trip people have made trip for shopping, people have made trip for education, people have made trip for their uh, jobs. And all these things has been extrapolated by means of the growth factor that because we are forecasting, so we need how much factor we can increase the particular things. A growth factor refers to any particular variable that contributes to the increase in transportation demand, capacity, or infrastructure over time. It can trace the expansion of transportation system, the growth in passenger of freight volumes, and the development of new transportation technologies. This is something that across classification is a general way of estimating the traffic generation or trip generation. Uh, at home, and this is basically constructing a table where the rows and columns have different attributes, and each cell in the table shows a predicted number of trips. This is usually derived from the data that you have surveyed. In the example cross application, the dependent variable is trip per person. The independent variables are dwelling type, single or multiple family, household size 1, 2, 3, 4, 5 people, and the percentage. So this is where I stop, and we'll discuss how this problem, how numerical problem can be solved.